Okay, I hope this works. Block 2, you are kind of shortchanged on class because of the assembly today, so you didn't get a full time to work. And block 3, you had lots of questions about the reveal. So I'm going to attempt to do this and record it, post it for you guys so you can check it out. I'm going to do it very quickly because I want the video to be forever. So you can always pause it, rewind, whatever, but see if this helps. So we're going to go through as quickly as possible and do all 17 questions from the review. All right. Determine if the system equation is consistent, inconsistent, and if it's dependent, independent. Before you can do anything, you have to solve it. To solve it, I have to put both of these equations into the same form. It doesn't matter what form, as long as they're in the same form. I prefer standard form, so I'm going to take the second equation and put it in standard form. The first one already is. So I'm going to move the 15 to the right and the negative 9x to the left. When you move it from side to side, you're doing the inverse operation. They become opposite signs. So this equation now becomes 9x. I'm also writing on a tablet I've written on for a while, so sorry if it's a little sloppy. Plus 3y equals negative 15. And then that top equation remains in this form. However, to simplify, to solve it, I'm going to have to do some elimination. And I have to multiply. I'm going to multiply this top equation by either 3 or negative 3. It really doesn't matter. I'm going to choose 3, even though I'd normally choose negative 3 to get opposite signs, but you'll see why in a second. So now the first equation becomes 9x. That's a really bad x. Just deal with it. Plus 3y equals negative 15. And the reason I chose to do just 3 instead of negative 3, I kind of knew ahead of time. I could see it happening. I have two equations that are now the exact same equation. That means they're going to have infinite solutions. That means they're collinear. So what does that mean? Well, if you remember, I have inconsistent, or consistent. I can't be both. I can only be one or the other. Inconsistent means no solutions. This is all on page 387 in your book where you wrote the notes. Consistent means you have answers. Okay. Do I have answers? Yes, I have an infinite set of answers. So consistent breaks down into either independent or dependent. Independent means one answer. Dependent means infinite answers. So that means that since I have the same equation, I'm going to have a collinear system. Both equations are going to have an infinite set of answers. They are consistent and dependent. I'm going to click consistent and dependent. And there we go. Moving on. All right. Let's see how I remember how to clear this. There we go. I'm correct. Numero dos. These two equations, this is a simple one. System of equations, they are parallel. Will they ever intersect? No. The intersecting point is my answer. And if they never intersect, I have no solution. Done. Some of these are way easier than others. Take advantage of the easy ones. Number 3, Clark is spending $46 on a pair of shoes and a new jacket. The shoes are X, the jacket is Y. Okay. Well, it's one pair of shoes X, one jacket Y, gives me a cost of $46. Second equation. The shoes cost $8 more than the jacket. Shoes are X. They are the jacket plus $8. They are my two equations. Now to solve it, I have a couple of options. Option 1, X is already isolated. I can just use substitution if I want. I can put Y plus 8 in place of the X. Option 2, I can decide to rearrange this second equation to say X minus Y equals 8, and then eliminate the Y's and solve for X. That's actually what I'm going to do because they asked me for the cost of shoes. Shoes are X. I need to solve for X. So I'm going to rearrange that second equation. That first equation is still going to say x plus y is equal to 46. The second equation, when I subtract y from both sides, will say x minus y is equal to 8. All right, they're already set to eliminate. Y negative y eliminates. When I add the equations, I get 2x is equal to 46 and 8 is 54. Divide by 2, x equals 27. X is shoes. Right there it says it. Shoes are x. Therefore, the cost of shoes is $27. Now, if you had done it the other way, if you had done substitution, if you had put the y plus 8 in place of the x, you would have solved and found out that y equaled 19, I believe. But y was a jacket. They wanted the cost of shoes. So now you have to take that 19 and put it back. I'll do that real fast just so you can see it, because that's how some of you know solved it. I watched you. You take this y plus 8, this is going to be really sloppy, and put it in place of x. So over here, I'll do it the second way. So y plus 8 substitutes in for x. There's another y already part of the equation, equals 46. Combine the y's, and while I'm at it, I'll subtract the 8. So 2y is equal to 38. Divide by 2, and y is equal to 19. That's y. That's jacket. I need shoes. So now take that 19 and put it back into where it came out of. You know I love my circles and arrows. So x is equal to 19 plus 8. There's my $27 pair of shoes. Either way works. Like I said a long time ago in this module, when you have these systems, there are multiple options on how to solve each one. Sometimes they're easier, sometimes they're harder. Sometimes you're more comfortable one way, sometimes you're not. I love elimination. Some people are happy with substitution. You do whatever you're comfortable with, whatever works best for you. All right. Quattro. Which system of equations would give the result when using substitution? Well, if I take a look at my choices here, first of all, letter D is not a system of equations. That's one equation. I can cross that one off immediately. I know letter D can't be my answer. Letter C says 0 equals and 0 equals. Where's the Y? No good. I'm down to just A or B. I use a little bit of elimination, multiple choice elimination to solve this problem. I'm trying to get this equation right here when I substitute. Well, these are both in slope-intercept form. These are both in slope-intercept form. If I substitute this in place of the y right there, my equation just says 16.9x equals 3.2x. That's not what this says. This says 16.9x minus 2.3, 3.2x plus 18. Well, look at this. 16.9x minus 2.3 goes over here, and it equals 3.2x plus 18. There's my answer. They didn't actually ask you to solve anything. They just asked you to say which two equations would substitute to create this equation. B it is. Okay? Oh, wait. I forgot to check the last one. You want me to go back and check it? Get the satisfaction of seeing the green check mark? There you go. All right, let's skip ahead to number 5. Let's see if I can eliminate, if I can erase all this writing. Maybe the toughest question on the whole test. If not, definitely second toughest. You've got 3 lines. Line 1 and line 3 are parallel to each other. Line 2 runs across them, looks perpendicular. Perpendicular. Okay. They want to know when I have a solution of -1, 3, that's this spot up here. That means that the solution -1, 3 is a solution to line 1 and line 2 being put together as a system. When I have no solutions, that means I need parallel lines. That's line 1 and line 3. And in a system with infinite solutions, that means I have the same line twice. That means I have line 1 twice, line 2 twice, or line 3 twice. They're going to have to be different forms, though, the equations. The issue is the forms of the equations. All these equations are not in good forms. They're in standard form. They're in no name form here. Y plus 4 equals negative x. That's not even a form. At least one of these here is in slope-intercept form. So I got to do some conversions to see what's what. But I know that this one is going to be line 1 and line 2. I know that this one, no solutions, is going to be line 1 and line 3. So let's see. Let's do the easiest one first. I'm going to do some converting on this bottom one. This equation is already slope-intercept form on the right. This one over here, I'll subtract 4 from both sides, and this will say y equals negative x minus 4. Well, look what I got. I got negative x, I got negative x, I got parallel lines. I got different y-intercepts. They must be no solutions. Negative x minus 4 and negative x plus 2. Well, if I look back up here, oh, can't do that while I'm on the pen. Look back up here. There's my y-intercept of 2 and my negative x slope, my negative 1. There's my y-intercept of negative 4, my negative 1 slope. That means that this one is my no solution. Drop it in there. All right. Let's take a look at the other two. The other two, I need one of them to have one solution at that negative 1 comma 3. And the other one, I need to have infinite solutions. I need to have the same equation. All right. Which one do you want to work with? They're both in standard form, both in standard form. I'll do the bottom one. Just the number's a little bit smaller. Whatever. 2x, 2y, negative 8, 3x, 3y, negative 12. I'm going to convert them both into slope-intercept form. So let's see. That means I'm going to subtract 2x and divide by 2. So y is equal to negative x minus 4. Subtract 3x, divide by 3. X or y is equal to negative x minus 4. What did I just make? Collinear, same equation. That must be my infinite solutions. Drop it in. And then you're done. If you want to check and prove it, you can. I know some of you want to check and prove it. You know who you are. It's okay. I'll do these again. Add 3x, divide by 3. So y is equal to 1x plus 4. Subtract 5x, divide by 5. Y is equal to negative x plus 2. X plus 4 and negative x plus 2. Where are they? Let's see. X plus 4, my y-intercept is 4 with a positive slope. That's line 2. And negative x plus 2, y-intercept is 2, negative 1 slope. There's line 1. So line 2 and line 1, there's that negative 1 comma 3 intersecting solution. Just proved what I already had done by process of elimination. If you had chosen to do that one first, it's probably the hardest one of the three. I tried to find the easiest one first. Okay. Tough question. One of the toughest questions on the test. One of the two toughest questions, in my opinion. How many solutions for this? This one's easy peasy. They're both in standard form already. Need to do some elimination. I need to multiply the top by either 3 or negative 5. I'll choose 3 because then we're going to have opposite signs already. So now this equation becomes negative 3x plus 3y equals negative 15. Right away I can look and I can say my x's will eliminate, my y's will not. That means I'm going to get one solution. Now I have to find out what it is because it says if the system has one solution, name it. Name it means what is the answer, not like, oh, I want to call it Carl. No. Hi, Carl. So let's do elimination. X's eliminate. Y's become 8y equals negative 15, and 15 makes 0. 8y is 0. Some of you guys freaked out. You're like, oh, no solutions. No, y is 0. 0 is a solution. Y is 0. Done. Now I need to go back and find x. I can use either equation. Top one looks easier because there's no coefficients, but there's a negative, there's a negative. I'll use the bottom. Y is 0. Replace y with 0. That means that 3x is equal to 15. That's 5 times 0 is 0. And x is 5. So my answer is, how many solutions? One solution. And that one solution is 5, 0. Look, 100 characters. I still have 81 left. I don't need to write 1,000 words. 100 characters is more than enough. How many solutions? One solution. Name it. 5, 0. Done. Use your words efficiently and effectively. You don't need to write forever. Can't auto check that one. That's what I had to score. Which equation can be substituted for x in the second equation to find the value of y? Horrible question. That's standard form. That's standard form. We're not doing substitution. We're doing elimination. This is just to prove to you substitution is not necessarily the easiest way. If you want to substitute something for x in the second equation, it's got to come from the first equation. So that means I need to isolate the x in this first equation. Isolate the x means subtract the 2y. X equals negative 2y plus 20. That's what's going to go into the second equation in place of the x. Super hard way to solve it. I'd never solve it that way. I would solve using elimination. I'd multiply the top by negative 2 and eliminate. But that's not what they asked. You have to answer the questions being asked. What goes in? Negative 2y plus 20. There you go. Check answer. It's so satisfying. Oops. Solve using any method you want. You know what I'm choosing. Choosing elimination. Every time basically I want to choose elimination. Really rare that I choose substitution. And I'll never choose graphing unless they force me. Standard form, standard form. Nothing eliminates yet. They're both opposite signs. The y's are easiest to multiply to change. Multiply this bottom equation by 2. I now have negative 8x. I have a plus 2y. I have a 12. This is gone. Negative 2y, positive 2y, they add to eliminate, so I'm adding the equations. That gives me a negative 5x, and it gives me a 15. So x equals negative 3. X equals negative 3. Drop it down, negative 3, bam. Put it back in. Put it back into either one. I'm actually going to go back and put it into that second one. Let's see if I can erase that. The original second equation. And the reason I'm going to do that is because the x coefficient is negative. The x value is negative. They make a positive. And my y is a coefficient of 1. So negative 4 times negative 3. 12 plus y equals 6. Subtract 6, 12 from both sides. Y equals negative 6. Jackpot. That was hopefully one of the easier ones. Like I said, some of these questions are easier than others. Some are hard. Some are very difficult. Sorry, lots of clicking. This is taking longer than I wanted it to already. I'm only on number 9. What are the steps? How to use substitution? Oh man, substitution again. Well, y is already isolated. Good. Put 6x plus 1 into the second equation. Since the first equation is solved for y, substitute 6x plus 1 in for y in the second equation. There's step 1. Good. Once I do that, I'd have to multiply this negative 2 times the 6x plus 1 and solve that. So solve the resulting equation for x. There's your step 2. Step 3, once you have x, now you need to find y. Substitute x into either equation to find y. And then step 4, write your solution as an ordered pair. Check the solution. Check means you can use the second equation, see if it's still the same. Right? Your solution is ordered pair. There's your final step every time. Not bad on that one, huh? 10. Any method you choose, I'm choosing elimination. They're already set up. The x's are going to eliminate. But look, the y's are going to eliminate too. What's going to happen? X's make 0, y's make 0. I got a 0 equals -1. Done. No more work to do. No solution because these numbers are not equal. If these numbers were equal, infinite solutions. Get this out of the way. Get that green check. Okay. If that other one wasn't the hardest question, this one might be. There's a little bit of confusing minute in here. Follow along. Logic, use your number sense. There are $2 totals, which means this is not a quantity and a value system. It's two different quantity systems, a lot like the ones on IXL where it was like, adult tickets and youth tickets for two different things and how much it cost. $2.50 to make sandals, $4 to make running shoes. $2.50 for sandals, 2.5 S. $4 for running shoes, 4R. That cost $2,500. On another month, April, the cost is $3,000. It says they double, that means times 2, the pairs of sandals. They didn't change running shoes. Running shoes still remains $4 each. Not to double 2.5 for sandals. I'm doubling the sandals. So it's not the regular number of sandals, it's twice as much. So over here, I'm just going to write that down. It's 2.5 times 2 times the number of sandals. Well, what's 2.5 times 2? That's 5. You're not really doubling the cost. You're doubling the number of sandals. But since you're multiplying, you can multiply in either order. You can reassociate it and multiply the two constants times the S. There we go. What am I set up for? 4R, elimination. I have to subtract. I'm going to subtract the top equation because that'll give me a positive result. Negative 2.5 and 5, positive 2.5s. 3,000 minus 2,500, 500 divided by 2.5. I want to say 200. Yes. Sandals is 200. See if that's a choice. Bam. Go back and find running shoes. Put 200 in either equation. I'm going to choose the second one because the second one has no decimals. S is 200. 5 times 200. That's 1,000. E plus, 4R running shoes equals 3,000. Subtract 1,000. 4R is 2,000. By 4. R is 500. 500 pairs of running shoes. Bam. Let's get that check. You got it. You getting bored of me yet? Select all of the ways that the system can be solved. There's all kinds of ways. Oh.
Good afternoon. Any student getting picked up, please report to the area outside of guidance. Any student getting picked up, please report to the area outside of guidance.
I don't know if that paused or not. That was Miss Rhodes. Select all. Multiple options. You have to check each one. Multiply the first equation by -4, then add. I multiply the first equation by -4. This negative y becomes positive 4y. I'd add to eliminate the y's. That's good. Multiply the second equation by 2, then subtract. When I multiply this by 2, this 3x becomes 6x. 6x and 6x, subtract. That's good. Multiply the first equation by 2, then add. That can be 12x, 2y. Multiply the second equation by 2, then add. 6x doesn't add with 6x. And negative 8y and positive, or negative 1y, nothing. That's a no. Multiply the first equation by 4, then subtract. If I multiply this by 4, this negative 1y becomes negative 4y. That's also negative 4y. If I subtract, they eliminate. I would expect you to get A. I'd expect you to get a B. He's a little tricky. Make sure you check them. Boom. Coming on the home stretch. Mandy solved using elimination. That's because Mandy's smart. Mandy says the system has no solutions. Is Mandy smart? Let's see. Elimination. I have two different forms. I'm going to take the second equation and put it into the standard form to match the first equation. So I'm going to add a 3x to both sides. It'll say 3x plus, oops, 5y equals 4. Get rid of this. I change the form. This is 9x. This is 3x. I can multiply by 3. Or this is 15y. This is 5y. I can multiply by 3. If they both multiply by 3, they're both going to eliminate. Multiply this by 3. And now that equation says, I'm going to put it down here. 9x plus 15y equals 12. 3 times 4, 12. The 9x eliminates. The 15y eliminates. 6 minus 12, or 12 minus 6. Either way, I'm going to get 0 on the left, 6 or negative 6 on the right. Do I have a solution? Nope. Mandy, you're a smart kid. Mandy says it has no solutions. Is Mandy's statement true? Sure is. Good job, Mandy. Maybe you should sit next to Mandy. Solve. Any method you want. Standard form, standard form. Couldn't be set up much better for elimination. Just have to multiply. 4 doesn't become 11, but 3 becomes 9. I'll multiply this by negative 3, though, because now I'll have opposite signs. So this is negative 9. Ooh, 9x. This is negative 12y and negative 12. Add them together. X eliminate. 11 minus 12 is negative 1y, or just negative y. 2 and negative 12, negative 10, which means y is 10. Let's fill it in. Now I'll go back and find x. I'll put it into the first equation, just so I cross off the bottom one. 9x plus 11 times 10 equals 2. Subtract 110, 9x equals negative 108. By 9, x equals negative 12. Negative 12. You want to check yourself? Put it back in that first equation again. You're welcome to. I encourage you to. Don't ask me if it's right. Test. Ask yourself if it's right. Put that 10 into that second equation too. The original second equation. It's easier. Numbers are smaller. 3x plus 4 times the 10 I'm putting in. 40 equals 4. Subtract the 40, negative 36. Divide by 3. I just confirm my answer is correct. I'm golden. Almost home. Systems of inequalities match it to the graph. Oh, man. Standard form, standard form, standard form. But it's the same inequality every time, just with different symbols. But it's the same x and y and 2x minus y, same 4 and 3. I just got greater thans and less thans or less than equal to's, I have to see which one's which. So let's do some quick converting. I'm going to put it over in this space over here. That x plus y, I'm going to subtract the x, and I get y, and I get greater than negative x plus, ooh, my face is in the way, plus 4. Second one, subtract the 2x, divide by negative 1. Y, divide by negative 1, flip the inequality, greater than equal to 2x minus 3. Let's see what that tells me. I got a greater than negative x plus 4. I got a greater than equal to 2x minus 3. Well, actually, I could have been a whole lot smarter than that. Wow, I did a whole lot of work for nothing. Check this out. I get a greater than and a less than equal to. I'm going to have one dashed line, one solid line. Dash solid, 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 dash dashed. No thinking required. I did it the right way. This is the easy way. I got a greater than equal and a less than equal. I'm going to have a solid, 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 solid. Bam. Can't get much easier than that. Greater and less and greater. 2 dashed. Drop it in. If you do convert on both, you can check your inequalities and see where they go. It works out. But I didn't even notice that my inequality symbols told me everything I needed to know. What kind of boundaries do I have? Answer. Jason graphed, didn't shade. Where is the answer? So let's see. Y is less than x minus 1. That is this line down here, the dashed line. Less than means he's going to shade below. He's going to shade down here below that dashed line. Okay. Second one, non-slope intercept form. Add the x divided by 2. Y less than equal to 1/2 x plus 1/2. That's my solid line. Less than means I shade below. Where I overlap? Right there. Region number 2. Got it. Last one, baby. Oops. What did I do wrong? Okay. Of course, now it's going to crash. Haha, here we go. Is it a solution? All you're doing is taking these ordered pairs, you're substituting them in. You don't have to graph anything. You don't have to do anything, convert anything. Just put these ordered pairs in. See if it works in both. And if it does, it's a yes. Doesn't work anywhere, it's a no. All right, let's do this as fast as I can. 2, negative 2. 2 is x, negative 2 is y. So this becomes negative 2. This is negative 2. Is negative 2 less than negative 2? No, it's equal. No equal to on that inequality. That's a no. Don't even have to check the second one. Once the first one doesn't work, doesn't work. 0, 0. Is 0 less than negative 0? Oh, negative 0. No, that's a no. Bam. I don't know why these aren't removing themselves. Sorry. Negative 5, comma 6. X is negative 5. Negative negative 5 becomes positive 5. Y is 6. Is 6 less than 5? No. Haven't even had to go to the second inequality yet. The first 3 have been just the first one, knocking out. Why am I doing the first one? It's easier. There's no multiplication. There's no nothing. Do the easiest one. Negative 2, negative 3. X is negative 2. Negative negative 2 makes positive 2. Y is negative 3. Is negative 3 less than 2? Yes. So far, so good. Check the second one. 2 times negative 2 is negative 4. Plus negative 3, that's negative 7. Is negative 7 greater than 2? No. Nothing's working. 5, -6. 5 is x. -5. -6 is y. Is -6 less than -5? Yes, it is. All right. Number 2. 2 times 5 is 10. 10 plus -6, that's 4. Is 4 greater than 2? Hey, I finally got a solution. Last one. X is 4. That's -4 then. Y is -5. Is -5 less than -4? Sure is. Inequality 2. X is 4. 2 times 4 is 8. Plus -5. 8 minus 5 is 3. Is 3 greater than 2? Got solution number 2. Check my answer. Man, I'm a genius. I hope that helps. I hope I didn't bore you to death. I hope I didn't waste my time doing this. Take your time. Think about what you know. Read the question carefully. Decide which method is best. Substitution, only if it tells you have to. Graphing, only if it tells you have to. Elimination, pretty much all the time. Solve away. Know your vocabulary. No solutions, infinite solutions. Inconsistent, consistent, and then independent or dependent if it's consistent. There's your answers. All right, signing off. See you in the morning.